So let's start this discussion. So like in this session, today we are going to discuss about the machine learning questions that have been asked earlier. So like we can discuss about the bias value instead of like L1 and L2 regularization. We can discuss the impact of activation function. We can discuss about the RELU, that how can the configuration might happen. We can discuss with the comparing with the value and boosting. We can try to understand the concept of physical velocity, and then I can go ahead with the technique like called cross validation. Uh, I can also try to understand the hyperparameters tuning in the machine learning. What methods can be used for hyperparameter applications. So that matter also I can go ahead. I can go ahead with GAN, like generative adversarial network. Uh, uh, so that part I can go ahead. Okay, that's completely fine. So vanishing gradient problem, I can go ahead okay, difference between the supervised and unsupervised and enforcement learning. Okay, I can try to understand about the SVM and how the SVM can handle the non-separable data like implicitly number analysis. How is it used for demonstrating in the concept of UI? That means
Butter? Water? Give me butter. Give me water.
Using neural network, how does affect training and model performance? Explain the concept of model assembly, what are the some assembly technique and how do they improve model performance? Discuss the concepts of feature scaling and normalization. Okay, and why are these techniques important and how do they impact model performance? So how they are used for sequential data tasks, like you can consider like LSTM is very important task. RME. Okay, how does expectation mapping, EM, purpose of realization in machine learning, and then you can consider cross entropy loss. That is also very important point, right? So you can consider like generative model and distributive model as well. Uh, you can consider like importance of feature engineering in the machine learning, and then you can consider like what techniques we can use for effective features for like some instructions. So, uh, how do tree-based algorithm like random forest and gradient boosting work, and what are the key difference between this method, right? So you can consider like a concept of hyperparameter training. What are the some common method for finding optimal hyperparameters for machine learning models? What is the difference between batch normalization and layer normalization? So these kinds of questions, attention mechanism, like it concepts sequential sequence. Uh, what are the example and application of the attention mechanism? That's what is used. What is the concept of auto-integrator and how are they used for unsupervised learning and feature extraction? Uh, we will discuss the use of transfer learning and deep learning. How can pre-trained model be adapted to new tasks? Right? Okay. Explain the concept of M1 score, how is it calculated, why it's related to. So true positive, false positive, what is the how is it related classification model? Describe its key matrix. Okay. True positive, false positive. Discuss the role of optimizer and training machine learning model. What are the some commonly used optimizer and how do they differ? Like you can say in training machine learning model, like optimizer, you can say like with the help of hyperparameters, like we can say like gradient clipping is the that method you can use. What is the purpose of organization technique? Dropout and regression, how do you help in preventing overfitting? Explain the concept of Bayesian inference, how it is used in machine learning for acoustic model decision making. Okay. What is the purpose of using optimizer and training model? How does it differ from traditional gradient descent method? Discuss the concept of model drift and what are the strategy can be used to monitor and address the it is change the model performance over time. So basically, let's come to the machine learning. Explain the bias variance trade-off. Okay, so that is the easy question. We're all getting that error due to the overly simplicity assumption in the learning algorithm, leading to overfitting. Error due to excessive sensitivity to fluctuation in training data. If high variance can make the model too complex. High bias, like can cause the model to miss important patterns. Regularization technique like NER regulation can help manage variances, which grateful as a completely the model simpler model, right? Simple methods combine multiple models to reduce variances and improve predictions. Combine multiple models to reduce variances and improve predictions. What is the difference between L1 and L2 regularization? When did you choose one? L1 regularization basically at the absolute value of the coefficient of the loss function, right? It can result in the space model where the sum coefficient becomes zero, right? Effectively performing feature selection, useful when you suspect that many features are irrelevant. Okay? Let the square of the coefficient of the loss function extend to sync the coefficient towards zero. Okay, but does not force them to be exactly zero. Useful when you believe that all feature contribute to the outcome but should be penalized from its value. Okay? Features are irrelevant. So when you have like multiple features that is irrelevant, so you need to do summation for all. And here you suspect for the very particular one that you found that suspect only you're finding that all feature contribute to the outcome but should be penalized for large values. Okay, so for large value you are penalizing, but here you are like suspecting with the many features that is irrelevant. So that is the last one. That is the issue. After the different activation function, like RELU is very easy to understand. Convergence network is space and efficient but can suffer from dying RELU where neurons stop activating. Right? This is the problem and speed of convergence. So it may face problem with dying RELU where neurons stop activating. Activation function we can say that is non-zero. Absolute values will be like -1 and 1, making it 0. It suffers from biasing ever generally performs better than scheduling. Gradient clipping involves stating a threshold value for gradient during the back propagation. If the gradient norms exceed this threshold, it is scaled down. This prevents the exploding gradient problem where gradient becomes extremely large and it applies the training process. Gradient moves okay. Gradient clipping involves setting a threshold value. Okay, for the gradient during back propagation, if the gradient norms exceed this, if the gradient norms exceed this threshold, it is scaled down. This prevents the exploding gradient value. Okay, how does gradient clipping work in training neural network? So basically, we want to deal with the back propagation problem, or you can say like there is a massive gradient problem. So it should not go too much back in back propagation, like there's a big threshold value. This prevents the exploding gradient problem where the gradient becomes exclusively large and destabilize the training process. Okay, so bagging can be a step aggregation like build multiple models immediately by training on different subset of data and evaluate their prediction. It reduce the variance and help you handle method coding. Like if you are considering the boosting, that boosts the model frequently, each taking the error of its decisions. It reduces bias and improve the model performance by focusing on difficult cases. Like gradient boosting machine and AdaBoost is one example. Overfitting, underfitting, you very basically when a model is too simple and to capture random patterns. When the model knows the training data to it, leading to poor performance in both the training and test data. Right? It can be added by some model using regulation and reply. Okay, right? That is a point that we need to understand. Again, like rule of involve number of layers and then we can say learning rate that optimize model performance. So we'll try to pick up the best hyperparameters like learning rate, number of layers, what can be the number of layers, what can be the learning rate. We'll try to choose and we'll try to optimize performance better. Like you can say SGD that we use for measure the in NLU. Here in machine learning the hyperparameters. It's crucial for the Git search, Git search meta is systematically test all possible information of hyperparameter. Randomly sample from hyperparameter space often faster than Git search and we can find the good parameters. Bayesian optimization user probability model to explore hyperparameter specifically, focusing on promising areas. How the generative adversarial network work and how they are some common application GN. GN consists of two network, a generator and discriminator. the generator creates fake data while the discriminator tries to distinguish between real and fake data. The generator improves its output based on the feedback from the discriminator, leading to increasingly realistic data generation. Image generation, creating realistic images. Data augmentation, generating synthetic training data. Style transfer, converting images to the different artistic style. What are some advanced techniques for handling imbalanced results? Like you can say resampling, class weight, you can say about smooth, smooth to create a synthetic example for minority classes, or technique like oversampling the minority classes, assuming higher weights to minority classes during model training to penalize misclassifications. So ensemble meta technique like balance random forest or easy standardization to handle the class imbalance. Explain the concept of dropout in neural network. Dropout involves randomly setting a fraction of neurons into zero during training. This prevents the network from relying too heavily on a particular neuron, forcing it to the learn more of a feature and reducing overfitting. Okay, generate better prediction. Advancing it in problem, very well. To the network, making it difficult for the network to learn. It may be using a technology like RELU and implementing batch normalization using it like LSTM and GURU for sequential data. Okay. The LSTM is basically using SGD. So again, that is RELU you can use for handling this problem. LSTM work, sequentially, and they are far better for handling this kind of problem. So, discuss the difference between supervised. That is easy, right? SVM handles non-linearly stable data by mapping the data to higher dimensions using kernel space. The transformer makes it possible to find a new space into the new space, even the data is not reached in the original space. Function like polynomial kernels or real basis function. Kernels transform the input function allowing SVM to fit complex decision boundary. Okay. What is the next question we have? To solve the SVM, use a technique called kernel check. The kernel check maps the features our generation based data might be very separable for the custom circle. Example, we can use a polynomial kernel ratio bus. So map data to high dimension display in polynomial function, map data to high dimension function. Okay, for constitutive circle, because there are like 2D data function circle, you check and concept like that. So again, like transform space high dimension RBF kernel, map the 2D in 2D data into high dimension space, let's say 3D or more, where the data points of class A and B class B might become separable with the hyperplane. It was like RBF kernel box. So much of computer cognitive side and maybe data and apply the conformal map data into the high dimension circle. In space, the linear hyperplane can supply the class. Now you can do example like you can separate the class and the SVM will find the hyperplane and use it to classify new data from the hyperplane. Okay, makes sense. So what is the PCA? PCA is technique for reducing the dimension of the data, but obtaining most of the variances. So transfer the data into new coordinate system where the first two coordinate principal component capture the most variance. Means center of the data, that is still the unit variance, compute the covariance matrix, find the features. Okay, so I think everybody is getting this point. Okay, so I believe everybody is getting clear, right? And transfer the data onto the new principal component, capture the eigenvalue network. This is the PCA, right? The mean center data and scale to the unit variance. So basically in PCA, you are doing kind of normalization. Find the feature vary with respect to each other. Okay. Calculate the identify the principal components. Okay. Transfer the data onto the new principal component project data. So basically you try to find out the value of eigenvalue and eigenvector. So you can get the value of principal component very easily from there. In the concept of model intelligence, what is why it is important and what techniques are used to feature importance, you can say accessing data of each feature using the shape or line. For concept dependency plots, visualize the effect of the feature in the projection. What is the ROC curve? The ROC curve is receiver operating the stick curve, shortcut through positive rate again the first positive. The positive rate, so the first positive various first. The IOC for measure the overall ability of the model. Different version. IOC well just from 0 to except for different Okay. But they're using a single data point at a time, it might see the plus local minimum and US okay. Update this using a small batch of data points. And combine the advantage of recipe and batch code on the same platform aligns between features. Convergence. Removing how will you handle the missing data? Okay. Interpretation you can say and interpretation you can say like estimating missing value based on surrounding data points. So usually for time series data but can be complex. Payment algorithm classify data point based on the majority class of its nearest neighbor. Calculate the distance between data points using metric like distance. Easy way to implement work well with the same process. Small to base, small size data set, completely expensive to large data operate. Now come to the CNN. Conventional layer apply conventional percentage feature from images. So basically, conventional layer you are applying the pooling layer, like designed for grid like data such as images like reduce the dimension of the feature map while preserving the important features like max pooling. Okay, so applying convention operation to extract feature from images. Now coming to the last layer, fully connected layer. Perform the classification based on feature stated by convention layer. So in this, we use the software function, so that can able to understand it, and then we are able to get out what happens to find. So okay, that's the scenario here. Then we can go ahead. What is the purpose of using dropout in the neural network? So how does it affect training and neural performance? So dropout is used to implement algorithm by randomly setting a fraction of math to 0 during training. The force the network to learn internet representation campaign technology in order to consume data. Explain the concept of model assembly. What are the some common assembly? Routing data or data investment, right? So the computer. Yeah. The model performance, like you can say, there's a concept like model assembly technique. So you have to like we have to deal with overfitting and underfitting. That means why I'm doing the overfitting, removing. That means it can improve the model performance. That means you will create a predictive model properly, and you will be able to generate it, lead properly. So like bagging, combine prediction from multiple models, change from different subset of truth. Decision it's sequentially build model to correct. Okay. Build model to previous ones. Real question. Okay. Data. Combine different models. Different model uses models to aggregate their predictions. Specify the concept of feature scaling. Feature scaling and also adjust the range of the feature value, making them comparable. Basically, you want to put it in. I hope you are getting also. So, not off at all. Right? So, yeah, that's fine. Then making them comparable. Well, you can talk about it. Feature scaling and normalizing adjust the feature of ranges value, making it comparable. This is an important algorithm sensitive feature scaling. Like you can say, you can use KNN is nearest stable to one scaling. And also we can do the plotting to understand the frame and behavior of the data. That's also fine. Subtract the mean and divides by standard deviation. Okay. It's, like you can say Z score test, the test, T test you can say for doing the feature engineering. Typically like 0, 1. Okay. X minus X star of the X star of the variances. Okay, RNA are designed for sequential data. There are two depends on the previous comparison to maintain a hidden state and step to capture temporal language. Address the vanishing gathering problem in vanilla RNN by using get input, forget output to control the flow of information and maintain the long-term dependency. They are not able to forget what is exactly have to forget, and they are not able to hinder a long dependency. But here you can say yes. The best application. So I believe everybody is getting a big answer. So it is basically it is reading the loss function. Okay, reading the square of the substring which lies the last option of the capacity, right? So at the speed value of the coefficient of the last function during the expression value. So that's completely fine. Cross entropy loss measure of difference will be effective probability and the true possibility. Plus present loss. These are the square difference between the prediction and true values. What is the difference between generative and descriptive? We can try to get it from here. We see what you have done. Okay, so we give you the description. Input across the byte and should have. What's good with the smaller batch? Not any improvement.
जल्दी से दिया जला लो चलो बाबू पहना था ना बाबू पहना था ना ऐसा बाबू पहना था ना बाबू को देखी थी पहन करता है इसलिए ये नहीं वो बाबू झुकेगा पहना ना ऐसे पहन रही थी पहना दो चलेंगे नीचे ना आप नीचे चलेंगे चलो झूला झूला के लाऊंगी झूला 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 आप को झूला झूला के लाऊंगी झूला झूले सावन की बरसे बदरिया की नगरिया बरसे बदरिया सावन की नगरिया करना है kalau ke dia jangan bedak tak mau biar dia ऊपर से नीचे ले गंदा कर दो नानी हाँ नानी आय आय मामा सोया है डांट दो उठो उठो इस समय नहीं सोते देखो मामा को देखो मामा उठ जाओ उठ जाओ
Okay, so thank you very much. This was still here. Any doubt, you can please let me know. You can just mail me or contact me. Thank you very much for your time.